Hello everyone and welcome back to the channel. So in our last video we covered tensors, which are the basic numbers that PyTorch works with. Today we're taking the next step and we will be diving deeper into neural networks. We will be making one neural network and even watch it learn in real time. So if you guys are ready, let's begin. So in our last video, one of you asked to see how neural networks work in practice and not just in theory. So in today's video, that's also exactly what we will do. So a neural network is basically just a function where you give it numbers and it gives you numbers back. The only difference is that the neural network learns how to improve its answers over time. This is the core fundamental of a neural network. So let's go ahead and import. So import torch, import torch.nn as nn. So torch is the main PyTorch library, and torch.nn gives us the basic building tools that we need for neural networks, like the layers, loss functions, and optimizer. So this is where we'll use Python, where PyTorch will handle how we make the neural network. So now let's go ahead and start building the neural network. So to begin, we make the class neural network nn.module. So this is the Python class we'll use for our neural network. Then we set it up with define init self super, and we use super init. Okay, so super will tell the PyTorch that this class will behave like a neural network, and this is just the basic Python setup code. So now we make the layer where we use self.layer equals nn.linear 1 and 1. So I'm gonna cover this code one by one to make sure we're all at the same point. So basically, this code here, self.layer, is pretty much the entire neural network. So 1 is the input number and 1 is the output number. And inside this layer, PyTorch will create two values, a weight and a bias. Now at the beginning, the weight and bias, they will all be random, okay? And furthermore, we'll go deeper into these values. However, just know that the one means input, and in the parentheses, the one is input and the other one is an output number. Then we also need to define the forward. Define forward self x. Return self.layer. Okay, so this function, again, it will define how the data flows through the network, meaning the input will go in and the output will come out. And as I mentioned this earlier, this is the forward pass. And now let's define what the network is trying to learn in this example. So we're going to give some example tensors like x equals torch.tensor 1.0, 2.0, and let's see, give it 3 examples, or let's give 4, just to, okay. And after we give it 4, we also give a y tensor, so torch.tensor 2, 4, 2, 4, 6, and 8. Okay, so these are our examples, meaning x is the input. For example, if the input is 1, then we take y, the corresponding y value, which will be 2. So, and so on forth. So if it's 2, if the x is 2, the output should be 4. And this is the example we want to use. However, right now our neural network has no idea about this rule, and we need to implement this rule. And with that being said, here comes the topic of the loss function, which is a very important part of training the neural networks. So basically, the loss function will measure how wrong the model is. So for example, if the model guesses 9 and the correct answer is 10, then the loss is small. However, if it guesses 50 and the correct answer is 10, then the loss is pretty large. And the goal of the training is simple. Basically, make the loss smaller over time. So train to improve on each answer and make the loss smaller each time. And we can just introduce this loss function by just with one line. We can type out loss fn equals nn.mse loss. And this is just, we're defining the loss function right here. And once we have the loss, we will now need to optimize our network. So we introduce the optimizer, which will change the model's weights. Think of the weights as tiny knobs, for example. So each step will turn these knobs slightly until we have the right knob. And this is pretty much the learning process made by the optimizer. So we just define model equals neural network. Then we add the optimizer called torch.optimizer sgd model.parameters and then we set the learning rate. Let's say 0.01 for now. And basically, this is once we have the loss, we will optimize our model based on that loss. And this is just a very simple version of the optimizer. And now that we're ready, we can now start training our model with the training loop. So let's go ahead and do that. So let's go ahead and write out the basic training loop, and I will be explaining it right after. So we say for step in range 100, optimizer dot zero grad prediction equals model x, then the loss, so loss equals loss fn prediction and y. Then we add the loss.backward and optimizer. Optimizer.step. Okay, so first we are going to loop the learning, so we're going to repeat learning 100 times. Then optimizer.zeroGrad, this will clear the old gradient values we had, because if we don't do this, the learning will break, so we have to reset them each time. Then prediction equals model x, so the model makes a guess, and the x is the x tensors we had, the list back then. Then according to the y tensors, which we want the output to be, we measure how wrong the guess was using the loss function. And as you can see, the parameters is prediction and the y tensor list. Then loss.backward basically figures out how to fix the weights. Okay. And based on that, we use the optimizer.step to update the weights. So improve the training. And this is the learning. This is the learning part of the entire model. So now that we have the training loop, a small training loop, 100 steps, let's watch this learning happen in real time. So basically, we just need to print. So let's go here. So we print the loss item. So print f loss dot item. Okay, so let's run the model. Okay, so it seems that we have a missing bracket here. So we need to add one more bracket. And this goes for here as well. So we need 2 pairs of brackets and 1. Okay. Here we go. And as you can see, the loss right now is 0.017. Now it's getting lower. Loss equals 0.009. Let's run it again. 0.0051. You guys can see it's getting lower each time, and this is a good sign. Lower, see, 0.0028, 0.001. So, and this just pretty much summarizes our previous ideas that each time we run it, so we run it 100 times, then print the loss, and you guys can see it's getting lower each time, meaning the function or the model is getting better at making the predictions and having a lower percentage of a wrong prediction. And this is the most important part to pay attention to in the learning, because if the number is going down, it means the model is learning. And this is the most important signal when you are training a model. Now we can also test the model. For example, we can add, let's add some code. So we go test, shall we say torch, we give the number, torch.tensor 5.0. Okay, then we print the model, print model test. Okay, so the model has never seen the number 5 because we have not included it over here in any of the tensors. So, and the idea of the model is to basically double each number we give it. So it was, you guys can see here, when we give it 1, we expect 2. When we give it 2, we expect 4. So it doubles. We expect a doubled outcome each time. So now that we give it 5, however, it has not seen the number 5 before in the list that we have given it. So this is a good way to test the model. So if it outputs something close to 10, that means it has learned the pattern. So learning the pattern is the most important part. Now let's run it. And as you guys can see here, it gave us a value of 9.93, which is really close to 10. That means the model has actually improved a lot and basically given us a correct output. And this is a good indicator that the model has successfully been trained and now somewhat has learned the pattern. And pretty much all the large AI models, they all work the same way, just like this. This is just a basic example, but they all fundamentally work like this. It's just with more layers, more data. However, the learning loop is the same for all the large AI models. So we covered a lot in this video, so let's take a second to slow down and recap what we just learned. So we built a neural network and see how it works and trains in practice. You saw how we define a model, how the data flows through it, how the model makes guesses, and even how we measure how wrong these guesses are using a loss function. And this is done through PyTorch, which automatically figures out how to improve the model. And the learning loop we saw, it is the core of every neural network that there is, from the simplest models like this to the largest AI models you hear about today. The core fundamentals are the same. And PyTorch really does make this process feel simple, but now you understand what's happening behind the scenes, and that's what really matters when we're learning. In the next video, we will build on this foundation and deep dive into deeper networks using multiple layers, and we can even cover other topics, which you guys can let me know down in the comments below which topics or any questions you have or which topics you'd like me to explore specifically. And if this video helped things finally click for you, make sure to like the video, subscribe to the channel, and follow along with the series, because everything from here builds on what we have just learned. Thanks for watching, and I'll see you guys in the next video.